Ready for B? All right, so let's take a look at that. Probably we'll go through that together too, so just go ahead and read through it, and when you're ready, we can go through it together.
Okay.
All right, now some of this you might be able to get through once we get started here. So, is the light going to be more or less intense after it gets through the wires?
Less intense.
Because only one type of oscillation is getting through. In fact, it should be kind of intuitive that it's going to be half as intense, because in a sense we're letting through half of the oscillations. You can see that the into and out of the board oscillations are fine, it's only the up-down oscillations that are not working. So maybe it's intuitive that we're going to have a new intensity that's half of the old intensity. So, notice that the problem specifically said, or you can't notice, but it said that the original intensity was I. So the new intensity would be I over 2. Or if we wanted to, well, they're using I, so we won't use S. We'll use I for intensity. Okay, now actually maybe we can finish this off now using some of the things we talked about previously.
So could we use these equations?
Yep.
Setting I over 2 equals that.
Yeah.
And solving for the peak of that.
Yeah, there you go. That's right. I guess we have to assume that this was an average intensity. They didn't say that, but otherwise we can't use the equations. So we'll assume that this was an average intensity. And then we already went over the equations.
So then just solving for
Mm-hmm.
and then taking the square root of that.
Good. You can just, since there's no numbers in this problem, it'll be conventional to leave it as a symbol.
And then using that equation.
Is there some way you can simplify that? Oh yeah. In fact, you could have multiplied both sides by 2 over here. Okay, good.
And then divide that by C to get B.
Good. Okay, good. You can simplify that more, but this is good enough. So this would be a good answer. You could have used this formula to find B, but it's simpler just to use our little trick over here. So that would give us these answers here. All right, so it kind of made sense here that only half the light was getting through, one type of oscillations. That gave us the new intensity. But then how did we find the electric fields? So we've seen a couple of equations now where we need these equations that relate intensity and field. What was the question asking for again?
For
The peak magnitudes. So again, that was a clue that we're using the right formulas there, because I'm looking for the peak magnitudes. Okay. I would say that's a hard polarization question.
And then can we go over this one?
Did you try this question in your own?
I I looked at it, but.
Or just look at it, okay. So the big lesson from the question we just did is that if you have a polarizer made of wires, the direction the wires are in is not the polarizing direction. There's a little logical argument that shows that the polarizing direction is actually perpendicular to the wires.
So is that always because the wires are conductors?
For any wires, yeah. And so if you're using wires as a polarizer, I guess that argument would always go through.